Hello guys, welcome to Ramta Solutions. Today we are looking at arithmetic sequences. We're looking at sequences. So, without any waste of time, let me remind you what arithmetic sequences are. You have seen this from grade 10. Now, they have the general term Tn, let me use a different color. They have the general term Tn equals A plus n minus 1 times d. Now, what this Tn stands for, it is 1. It is a term value. Let me increase my font. It is a term value, which we also say it can also be a general term, or sometimes we call it an nth term. Sometimes we call it an nth term of the sequence. Sometimes we call it an nth term. Okay? Now, this is what we call our first value. This is a term number. Okay? This is a term number. This n is a term number. Now, this d is what we refer to as the common difference. Okay, is what we refer to as the common difference. Now, this equation, when simplified after you have plugged in your a, your n, and your d, or rather after you have plugged in your a and your d, it'll look like a straight line graph. Remember, your straight line had the form y equals mx plus c. Alright, so you call these arithmetic sequences. Otherwise, they are also called linear sequences. Okay, now let's talk about the common difference. Now, so what we're going to do, we're going to look at a d, which we call the common difference. Maybe before that, let's consider a pattern or a sequence T1, T2, T3, T4, and so forth. So, when we look for a common difference, it is basically the difference between two terms. So, this will be your common difference. So, your common difference is term 2 minus term 1, which is the same as term 3 minus term 2. It's also the same as term 4 minus term 3, and so on. Okay, so this is how you calculate your common difference. Okay, this is how you calculate your common difference. So now, again, I want you to know your exam will ask you to find this term, which will be further reduced to something like this. Sometimes you will not be given a sequence. You can be given a graph, and then ordered to find your general term. Okay, you must know, as long as you have a graph which is a straight line, you can find your general term. Okay, so let's look at examples without any waste of time. So for our examples, let's find the general term. Okay, let's find the general term for the following. Maybe let's try 3 exercises. 1, 2, 3, 4, and so forth. Number 2, I will try maybe 5, 10, 15, 20, and so forth. Number 3, let's try 23, 19, 15, 11, and so forth. Okay, now let's then deal with number 1. Remember, you can find the general term by inspection. By just looking at the sequence, you can basically predict or tell what the general term is. When I look at the first one, I say our general term is n, but let's see. Now let's see. Number 1, we had 1, 2, 3, 4, and so forth. Remember, I said our D is T2 minus T1. What is T2? Here is T2. The second term is 2. What is our first term? Our first term is 1. Therefore, our general term is 1. However, I always advise you do this. 2 minus 1 is 1. 3 minus 2 is 1. 4 minus 3 is 1. Therefore, our D is 1. Now, we're going to get our general term. Now we say Tn equals A plus n minus 1 times D. You remember, our A was 1, which is the first term, was 1. We're going to leave n as it is. Our common difference was 1 as well. So what is this? This is 1 plus 1 times n is n. 1 times 1 is minus 1. Therefore, our answer is n. Our general term is n. Okay? Now, let's go to the second example. We had 5, 10, 15, 20. Let's see. 10 minus 5 is 5. 15 minus 10 is 5. 20 minus 15 is 5. Therefore, Tn equals A plus n minus 1 times D. What is A? A is 5. And what is D? D is also 5. So what do we have here? We have 5 plus 5n minus 5. Right? Therefore, what does it mean? It means Tn equals 5n. Can you see it? So think about it. Maybe you are not sure of whether your general term is correct. What you can do, I will say for a test, I will say let's look for the third term. The third term, where there's n, I put 3. So it will be 5 times 3, which is 15. Let me go back and check, confirm rather. Here is it. So it means our general term is correct. Now, let's go to the third one. Now, with the third one, we had 23, 19, 15, 11, and so forth. So with this one, again, I will do that. 19 minus 23 is minus 4. 15 minus 19, it's still minus 4. 11 minus 15, it's minus 4. Now, we say Tn equals A plus n minus 1 times D. What is A? The first term here is 23. What is our common difference? Negative 4. Now we have 23 minus 4 plus 4, or minus 4n, sorry. Now we have, when I look at it, we have negative 4n plus 27. Remember I said, if you are not sure, you can test. Let me test with maybe term 4. Okay? It's going to be minus 4 into 4 plus 27. What is it? This is minus 16 plus 27. This is 11. 1, 2, 3, 4. Yes, it's 11. Right? So this is how we find our general term. Okay, when the question asks you to find the fourth term or whatever term, you just, where there's n, you just substitute that value that you are given into your general term and you solve for the unknown. Okay, all right. Now I'm going to give you another example. I'm going to give you another example. Let me call it example 2. Let me call it example 2. I'm going to call it example 2. So example 2 says the third term of an arithmetic sequence Tn equals a plus n minus 1 times d is 17, and the ninth term is 41. Determine the values of a, d, and the general term. Or maybe let me not say and, of a and, okay, of a and d. Also find the general term. Okay, also find the general term. Okay, so this is the question that we are looking at. Okay, this is the question that we are looking at. So you remember we had our solution. Maybe let me change the color. Our solution, we had, by the way, Tn equals a plus n minus 1 times d. So we are given the third term, so meaning T3. We don't know what is the first term, so where there's n, I will put 3, so it is like this. And we also don't know what is d. So they say this third term is 17, meaning T3 equals 17. So I will say this is, oh, this is a plus 2d because 3 minus 1, right? I'm going to call this one here equation 1. Right, because we are given the third term, which means the term number is 3, right? And we are also given the term value, which is 17. Okay, cool. Now, and then they say the ninth term is 41. So let me go to that. So T9 equals a plus 9 minus 1 times d. What is the ninth term? They said the ninth term is 41. 41, okay? So I will say this means we have 41 equals a plus 8d. I'm going to call this one equation 2. Alright, I'm going to call this one equation 2. Now, we are looking for a and d. So, us looking for a and d, our problem is that we can't solve these things directly. So what we can do is we can solve for a and d simultaneously. Alright, we can solve for a and d simultaneously. So let me just write the statement: solve solve simultaneously. So solve simultaneously. I will say equation 1 was 17. Equation 17 equals a plus 2d. Equation 2 is 41 equals a plus 8d. Therefore, oh sorry, this is equation 1, this is equation 2. So I will say equation 2 minus equation 1. Okay, so I will say equation 2 minus equation 1. Let's see. If I say equation 2 minus equation 1, I'm basically saying this one here minus this one. So let's start with the right hand side. 41 minus 41 minus 17, it looks like it is 24. A minus A, it's 0. I'm gonna leave it there. 8 minus 2, in other words 8D minus 2D, it's 6D. Now what does that mean? It means here we have D equals 4. Alright, it means here we have D equals 4. Now that you found D, you can substitute D into either equation 1 or 2, and it'll give you the value of A. You are basically saying, let me show you. So now I will say substitute D subs into, I prefer equation 1. When I substitute into equation 1, I will get 17 equals A plus 2 into, I got my A, 2 into 4. I'm going to the next page. We have 17 equals A plus 8. What does it mean? This means A equals 9. Right? So we solved the question. Now, to find the general term, we will say Tn equals A plus n minus 1 times D. What is A? It is 9. What is D? We said it was 4. So this is 9 plus 4n minus 4. So this means our general term is 4n plus 5. Again, you need to test. You need to test if this is really working. I'm gonna try with term 9. Okay, I'm gonna try with term 9. Okay, term 9. 4 into 9 plus 5. So this is 36 plus 5 equals 41. When I look at this, it is exactly what the question gave us. The ninth term is 41. So this means our general term is correct. Alright guys, with that being said, oh, I can't close it as yet. Now let's look at when you are given a straight line. Right, when you are given a straight line graph. Right, when you are given a straight line graph, so you'll be given, remember by the way, Tn equals A plus n minus 1d. Something you should know is that n is an element of an integer. Again, n is greater than 0. Okay, n is greater than 0. Okay, so you will have a graph. It can be, however, it can be like this. It will never touch. This is your Tn axis. It can touch here. However, be careful. This is your n axis. Let's call this one 0. And this could be 1, 2, 3, and so forth. So your graph could start here. Okay? Or you can have the same graph. Your graph could also start here. Remember, this is 1, 2, 3, and so forth. Right? So what I'm trying to show you here is that sometimes they will say this graph represents a pattern or a sequence, and from this graph they will ask you to find the general term. You do, when they say find the general term, it means use your knowledge of finding equation of a straight line, and that equation of a straight line, remember, you're not gonna say y equals whatever. You're going to say Tn equals whatever, and from the knowledge of your straight line, you know what is y-intercept, you know what is whatever. All right, you know what is whatever. Okay, so guys, you apply this and you will never go wrong. Okay, all right, guys, I hope you enjoyed your straight line or rather arithmetic sequences. So see you next time. Bye bye.